Assalamualaikum warahmatullahi wabarakatuh. My name is Putra Farizi Azim bin Azman. Okay, today I would like to share to you guys a simple step as an example for the observation on the microstructure of cast iron experiment being done. So let's try to check it out. cast iron and steel is based on the carbon percentage, which is the steel carbon content is less than 2.4 weight% of carbon, but the cast iron carbon content is 2.14 to 4.3 weight% of carbon. Okay, based on it, the hardness, the steel have a low hardness, but it can be hardened and tempered. But the cast iron have a high hardness because it is hardened by heating and sudden cooling. That's all. Okay, grey iron is weak and brittle in tension because the pointed and sharp end of graphite was formed, and the tip of the graphite flakes act as a point of stress concentration. That's all. The comparison between Nidola and white cast iron is from the composition. Okay, first we know that white cast iron have 2.5 to 4.0 weight% of carbon, and silicon is above 1 weight%, and 0.6 weight% of manganese. But the Nidola cast iron have 2.5 to 4.0 weight% of carbon, and 1.0 to 3.0 weight% of silicon, and 0.05 to 0.09 weight% of magnesium. Okay, based on the microstructure, the white cast iron have a perlite and cementite, but the Nidola cast iron have a Nidola or spherical like graphite structure in perlite or ferritic matrix. Based on its characteristic, the white cast iron is very hard, brittle, and not wettable. But the Nidola cast iron have a high ductility, moderate strength, and high corrosion resistance. For the conclusion, in a whole, all the objective stated was achieved. By applying all of the steps, such as put the sample on the workstage, then observe it with an optical lens. We also can see the image of the microstructure more clear by adjusting the coarse focus and switch another objective lens with a zoom capability of times 10, times 20, times 50, and times 100. In the end, we can observe the microstructure of the cast iron clearly. Next, we also achieve to identify the classification of the cast iron based on the characteristic of microstructure obtained. For example, if the microstructure obtained contains a graphite flakes surrounded by a alpha ferrite or perlite matrix, so it is identified as a grey cast iron. Next, if the microstructure of the samples contains a Nidola or spherical like graphite structure in perlite or ferritic matrix, then it is classified as a ductile Nidola cast iron. However, the sample is classified as a white cast iron if there is a perlite and cementite in the sample microstructure. Lastly, we can classify the sample as a malleable cast iron if the microstructure of the sample have a clumps, which is rosette of a graphite surrounded by a ferrite and or the pearlite matrix.